Roundtable started. Welcome everybody to our Central Ohio Stormwater Roundtable. It's great to not see you, I guess, huh? I mean, hopefully we got to get used to this new technology. So feel free to use this. We like these as roundtables, like Brooke was saying. Keep the conversation open. This is the new reality, so we got to get used to some of these new technologies and how to use them. So feel free to get on that chat box and leave us some comments if you need or questions asked. We'll get to them. We'll try to stop at the end of each kind of segment and maybe answer some of those questions if you have them. The Wild Ones are sponsoring this roundtable. If you don't know who they are local advocates of native plants and native landscaping. And if that's something that you have interest, I would encourage you to take a look at their website, join in some of their activities, and be involved with that. And we appreciate their support on this. I want to also thank our community partners. They're the ones that keep us running and able to do this kind of outreach and training throughout the year. And again, like I say, they're very important to us, and I hope they find this useful. We are looking at continued training opportunities. This will be the last roundtable for the year, this year, but then we have Stormwater Awareness Week will be coming up in October, the 18th through the 24th. And we'll have some training opportunities there. I would encourage everybody to join in on the Ohio Stormwater Awareness Week. We are expanding that statewide and hope to get a lot of participation this year on really a broad statewide level. So there's opportunity there to access that. We'll also be having doing some of the MS4 training starting that week, looking at I'm going blank here, the minimum control measures in the stormwater permit for training purposes to communities. We'll start a series of those based on the MCMs that week of October 18th for training opportunities. Brooke, we continue to have the CWP webinars. There's still some left this year to participate in.
Yes, there are. CWP has been nice enough with everything that's going on to let us share some limited links so folks can view those remotely, which we used to do in our office, obviously. There are some that are still coming up, so I will share the Eventbrite link in the chat there so folks can kind of see what's still on the horizon. They just had one yesterday on IDDE. If anyone's interested in that and missed out on joining in, I can definitely forward you on some resources and the recording for that once it's available next week. So just shoot me a message and we'll get that to you.
So feel free to take advantage of those training opportunities. That's something, without doing in-person or large group kind of trainings, we need to kind of reinvent some of the training opportunities for our partners, and you need to be able to access those and document them and have that training shown in your annual reporting. So be aware of those. Feel free to contact us if you need any more information on that kind of thing. Am I still seeing the poll information up, or is that just my screen?
Yes, I'm talking. Yeah, just try closing your box. I think I fixed it.
I got it. Yeah, okay. So context here. Let's talk about ponds a little bit. When we talk about ponds, everybody conjures up some different ideas of what a pond is. But first off, let's look at natural or created ponds. I would offer up that most of what you see day in and day out are not natural ponds. We are in the glacial till region. What we see as ponds are mostly created artifacts of what used to be around here. You know, if we look at our ecological past, the kind of thing we're looking at here is, you know, these were forested lands, likely vernal pools. If we did have larger ponds, you know, those were kettle hole ponds that were left over from the glacial advance. But most of our ponds were more of the vernal pool aspect, deep forests, shallow water, and that's the kind of the natural pond that was here. And if we look at, you know, the species that we have here, these two come to mind particularly for me, because what I see here is we are kind of the epicenter for diversity of these two species. You know, our salamanders, we have a ton of different species here. You don't see that. These aren't our typical pond type species. You have to have waters that are ephemeral and perhaps disappear completely throughout the year, and it limits the fish and the predation on those, the larvae of salamanders. And then you have mussels, freshwater mussels. You know, the Big Darby is probably the epicenter for diversity for freshwater mussels in the United States. You only get those, you know, both these species are long-lived individuals. They like stable environments. So they've developed in these stable creeks where you had, you know, stable base flows, stable water quality. You didn't have the flashiness or what we see today as far as stormwater input. That stormwater input was filtered through vast forest areas. It made its way, you know, through these forests. Between, a lot of it didn't even get there with the vernal pool aspect. These were storage areas. You know, so what I see when I look at these two species is that ecological past that we're dealing with. And when we look at ponds today, this is not the kind of natural system that we had, that most of our native plants developed from. So why are ponds important? You know, what kind of, you know, this is what we're looking at for that ecological function. What kind of services do they provide? Floodwater storage, you know, water quantity. I think this goes to any pond, whether it's created or natural. Floodwater storage was a big part of that. And I would offer up that the natural systems that were stored a lot more of that water and really sequestered that away from discharge to the creeks. That discharge to the creeks was fed through the groundwater base flow. Channel protection, you know, that's a big one because of that storage and that slow release of the water. You know, these vast forested vernal pools and forested systems had buffered the streams from that, and that channel protection was there because it really was a much less of an event occurring on these channels. Water quality, both physical and chemical. You know, you've got uptake, biological uptake, you've got the chemistry of the water chemistry occurring, and then that opportunity for biological water quality is that habitat. You know, we see that across the board, whether it's created ponds or natural ponds. Now, the extent of how much there is and how much they do really depends on the pond and what the functions are like. So that's kind of what I want to talk about a little bit. And a lot of our presenters today, I did fail to mention. So we've got, we're going to have Corey Richmond from Aqueduct here to talk about, you know, what does professional lake management look like? What do they do? This is really our opportunity to ask questions of them, you know, maybe make some suggestions, look at how we manage ponds and what we can do to promote a better system. Mark Dilly's going to be with us. I see he's here. Yay, good. I'm glad to see you made it, Mark. Local environmental consultant, Mark, general all-around good guy and longtime friend. He's done a lot of work around the area with ponds and stormwater ponds in particular. So I'm going to really talk a little bit to stormwater ponds and the effects of stormwater on ponds. And we'll have our professionals chime in here after I'm done on my soapbox and let them chime in on things. So what I have up here, this is right out of the rainwater manual. Here's your typical pond design. You can see it's got the permanent pool, 6 to 8 feet depth, aquatic bench, safety bench, various levels of channel protection level, design storm event levels. And if we look at this more closely, there we go. We're taking care of all of these environmental services through volume control. And that's really how modern stormwater approaches these environmental services in ponds, is through volume control. So you can see there, your permanent pool is covering that aquatic bench. There's your emergent zone and that chance for biological uptake. You got a water quality elevation up there. Hopefully that's that area of seasonal high water in your pond where perhaps the emergent vegetation's getting saturated and you're getting some of that uptake. Channel protection level up a little higher for those regular storm events that are occurring, and we're keeping that volume sequestered, and we're making that storm event, we're discontinuing that storm event from the channel. And then you've got your 10 and 100-year levels for localized flooding and larger storm events. So why does that become important? I took this out of the TMDL for the Lower Olentangy watershed. This is a summary table of reductions that is recommended in this document. TMDLs is something that I see we are moving towards more and more. I've been doing this for about 30 years, been through a lot of administrations. The political will comes and goes, but in general, I think water quality is one that is kind of a bipartisan problem. Everybody kind of agrees when the problems come that we need clean water. So TMDLs are becoming more prevalent in design, regulation. We see that in the Great Lakes. We see that in the Chesapeake Bay area. These large systems are becoming important to us to preserve. And I would argue that they're all important to preserve. We need to look at these environmental services and how do we protect them. So something that's in this TMDL summary, we're looking at total phosphorus, TSS, total suspended solids, and fecal coliform. These are kind of the baseline standards of things that we need to remove from our water quality, and how do we go about that? You'll notice there are percent reductions on the MS4s that I've got the arrow at. So total phosphorus, 9%. Pretty small, almost like 10% reduction in that total phosphorus. That's a non-point source number, and to do that is very hard, I would argue. That last 10% there, how do you get that removed? What do you do? What are the practices that can occur there to do that? TSS, total suspended solids ponds are very good at that. You get water, stopped and slowed down, allowed to settle out, you get those solids coming out of there pretty easy. So I think we're good on there. But that total phosphorus, I want you to key in on that. That's almost a 10% reduction in the pounds per year, which is a non-point source type of situation. Let's take a look at a typical stormwater pond. Here's one I consider, pretty typical design. It's based size-wise on the runoff potential for the development. So, that dictates your size and your volume that you need. They're usually stuck in the lowest corner of the property, so it discharges. You can see this one. If you can see my cursor, here's the inlet here, and there's a head wall where those contours get really tight, and the discharge is off on the other side. You've got a nice long flow path, irregular shape because, well, that's volumes they needed, and that was the parcel that they figured they could stick this pond into, successfully. They probably needed some fill for the area. You can see some of the contours for the areas and the streets. Obviously have had fill added, and that's a lot of times why these occur. So you get stormwater ponds placed not because of the environmental services that they're providing. They're being placed there a lot of times in areas that they might be too low. A lot of them are placed in floodplains, which in a lot of cases is not allowed anymore, but because they're unusable in any other form, you get the stormwater ponds. They might have been wetlands or wet areas that become ponds. It's usually the discarded properties or the less valued properties that get turned into the stormwater pond. Tight banks, you can see the contours, you can see the shelf, vegetated shelf that runs. I like to call that the hula skirt that runs around the edge of it, and then a lot of open water and deeper water areas there. So there is that head wall. Here's the live picture of that pond. You can see it's maintained turf down to the edge. Little fluctuation there. You can kind of see where this is probably typical of your channel protection volume, where you get that, seasonal high, regular fluctuation of water, and then of course larger storage that's going to be up above that. Notice time of year you wouldn't see much vegetation, but even so, if there were, say, cattails or even Pondidaria and Sagittaria, things like that, you'd still have dried clumps of vegetation. So you don't have any of that kind of situation here. Again, just to show that, those are 3-to-1 slopes, 4-to-1 slopes, maintained turf down to the edge, and then very little emergent vegetation, nothing on the shelf, and you see the algae that is on the bottom. I'll mention also that this pond, as soon as you step off the edge, was very mucky. Black anoxic soils were right at the edge there, and very little vegetation on that. Here's the cul-de-sac, the curb line. So this is the kind of loading that you're seeing. This is a typical year's kind of loading going on in this. This is where you get that TSS reduction. But think about, that is the one curb line going into that pond, and this is going on year in and year out. So a lot of loading going in, a lot of sediment loads going into that pond. So if we're talking about good habitat, what makes good habitat? Well, if we're really focused on a habitat kind of aspect, you've got to look at that emergent zone. This is where the plants are going to be. They're talking maintain a variety. It's not just a cattail pond. It's having that variety that provides structure. It provides different forms of food sources, and even to the point of pollination, things of that nature. Structure is very important. That edge effect, the transitional areas. I always tell people, having that edge effect there, you have vegetation along the edge, it really keeps the geese out. Geese do not like water that they can't see to and safely exit and enter the water from. So with a vegetated edge, you can really reduce your goose population and goose problems and maintaining good coverage of those plants. But now the reason I show this is also look at that littoral zone and how wide that is. I like this just because it kind of illustrates how narrow your zones typically are in ponds. Whereas if we look at natural systems and talk about that, here's more typically the situation. You have a shallower zone for plants to occur in, and this is just an example of what that zone could look like. And you're only talking about 8 inches of water fluctuations, but maximizing that edge effect by having a shallower plant zone, having an area that you can get some coverage on your pond and have some effects on that. So here's a typical stormwater pond. I like this one. It had a good plant shelf to it. It's been maintained for some species diversity. And I'll have you know that there is not a sign of a goose around this pond. They do not habituate this one. They do not like that, even though it's surrounded by turf grass and industrial setting parkland areas. Absolutely no geese in this. So here's a project. I want to get into it a little bit about, so what can we do? And I think Mark will really hone in on this a little bit more. In fact, this is Crawford Farms. He had he'll probably have something to say about that in his presentation. This was a stormwater pond that typically was nothing more than that higher flood flow attenuation. So any water that flowed into this basically came out the inlet pipe and went out the outlet pipe on any of the other events. And the large area that you see behind there in that top picture was infrequently accessed. So we've gone in there and changed up that flow. Now we've got a 4-bay. If you look at the bottom photo is something, just after construction. You can see a flood flow channel that takes water kind of out and around the field. And now the inlet is separated from the outlet by a large path flow. And that water's got a long path to take before it discharges out of the system. So it's providing a lot of habitat. This is all planted back in natives. And it's a much more usable system. Something else we gave a little try with was the option of floating islands. A lot of times when we look at some of these areas that don't like the vegetation, this happened to be on a golf course. A lot of those water hazards were in play, basically, and they don't want tall vegetation in those areas that are in play. So they maintained it down to the shoreline for golfers to play through. So what do you do in those cases? How can you add some diversity? How can you add some uptake to these systems? So we tried a little demonstration project with floating islands. And this was just one example here. We did several proof of concept kind of things. These were something we viewed as something that watershed groups or private groups could do very simply, very easy, add some structure and some diversity to their ponds, and hopefully provide some uptake of nutrients in that respect. So here this was shortly after planting. You can see after a season's growth, a lot of vegetation comes out on that, keeps it out in the water. It's a very, very good way of adding some plant structure to a pond. There is materials out there. This is the Biohaven floating island that There's been a lot of work done into this. It is one of these tools that we have in our toolbox, and can be used depending on the situation. I would note, and something I think that our tests kind of confirmed too was, these islands, these were used in wastewater treatment ponds. 35% of the pond was covered with these, and they were using linear compressor and air diffuser to circulate that water, to get more contact with that. And that was something that I wanted you to key in on this conversation. In looking at some of when I originally looked at some of their results, I was a little disappointed, quite frankly. You can see the difference, the colors are the different treatments. So the red is the mat alone, no vegetation. And then they looked at plants, soft stem bulrush and pickleweed, and what the percentage of reduction was based on these different treatments. And if you look at that, we're looking at just the controls were going from about 35% to above 60% reductions. Not much difference between the vegetated mats or the mats themselves in that reduction in nutrients. So, like I say, when I looked at this, I was a little disappointed that the plants weren't doing a real major job on the uptake of nutrients in those ponds. If we look at some of their parameters and their sampling data, total P, you see the April sampling, and then you notice in the August sampling, we've got a minus 53%. That was exporting phosphorus in August. What happens in August? Plants senesce. It's fall. Things are dying. Things are going back into the system. So this kind of prompted me to take a look at the phosphorus cycle. What are we talking about when we talk phosphorus in a pond? One of the big differences with phosphorus, phosphorus and nitrogen are really our two big ones that we're looking at for reduction. Nitrogen is primarily atmospheric based. I think it's 5% of our atmosphere is nitrogen. So it's related to air interactions. Yeah, we get acid rain that comes off and gets into our water. But when we look at phosphorus, phosphorus is really a surface water condition. This was a material that is primarily from leaching and runoff of water. So it is water-based. Nitrogen is air-based. And that's something we really need to consider when we look at these systems on how we manage them. Phosphorus, I would offer up, is the one component that's going to dictate your algae control. And how do we deal with phosphorus in the water column and on our inputs into these ponds? When you look at this cycle, when I look at that and I see that, I look up here and I see this right here. I don't know what everybody sees there, but what I see is export. That's phosphorus that is leaving the system. And if it's not going into the shallow sediments or deep sediments, that's being, the only other option you have is that export. And I would offer up that by having habitat in those ponds, what you're doing there, phosphorus is related to ATP. ATP, if we remember back to biology 101, that is the fuel of photosynthesis, that is the fuel of life. Adenine triphosphate, 3 molecules of phosphorus. This is what drives life in these systems. This is what drives the phosphorus system. So it's really a mass balance equation. If we have inputs into these ponds that are above and beyond what the system capacity is, we're going to have these management problems. And this is what I would offer up as the problem with algae. We're seeing this in Lake Erie. These are, it is that phosphorus transport and how it's getting into these waterways. So looking at that and thinking about that export, I think if we manage our ecosystem services of these ponds, there's no reason we can't do this in stormwater ponds. I don't think it's being done. And there's a lot of research that's looking at old ponds, senescing ponds, and the chemistry that's involved in those ponds and those sediments. And perhaps we are exporting phosphorus at this point, legacy phosphorus, that has been stored in sediments for a while. We've done some sampling here around town on some of the creeks, and what we see is that there's a phosphorus export going on, and we've already limited phosphorus in fertilizers. So we don't know, it's not coming off of people's lawns in the urban setting. Where does this phosphorus come from? Is it pet waste that's being generated somehow? Animal waste, something like that. We don't know where this is coming from. So some of the things that, some of the solutions that I've seen, here again, we see floating islands. This is taking floating islands to the next level. These are systems where you have water drawn into the system and filtered through the plants. Now, think back to that data that I showed, and what happens if we're not removing phosphorus. I mean, these systems are great. Those plants are doing a great job at uptake, but in the fall, they're going to start senescing, and they're probably going to be exporting phosphorus at that point. So we need to think about systems that are going to export phosphorus. If we have systems like this, floating islands, I'd recommend that you've got to take the green off. That's where that phosphorus is stored at. So we have to have harvested systems like this. If those systems were just native wetland plants, there's got to be that harvest mechanism at that height of sequestration in the plant material that we're taking off and removing out of the system. I could see these transformed into rice paddies, and rice has got one of the highest phosphorus contents of any of the grains. What a great thing to have systems like this set up where you're actually farming that phosphorus in these water areas. This might be a solution for something like Grand Lake St. Mary's or even up in Lake Erie. Turn these into rice paddies that you're finally exporting that phosphorus out of the system and using that phosphorus. Phosphorus is a very conserved element in nature. We don't see high phosphorus levels in natural systems. When you see clean, clear water, they're pretty low in phosphorus. That's being used to its maximum extent. It's being quickly recycled, and it's being quickly incorporated somewhere else. That's what fish bones are. That's what, when a turtle crawls out of the pond over into the next pond, you're looking at some phosphorus export from that pond there. So that, again, is why, I think habitat is an overlooked value of stormwater ponds that we can really incorporate into these systems.
Hey, Dave, if I can just pop in for a second, I thought there was a funny comment in the chat box there.
Great.
From John asking are you saying that we need more predatory wildlife to remove organisms to manage phosphorus?
There is that aspect. I would say yes, but that's just part of providing habitat. It's kind of like a build it and they will come situation. And these stormwater ponds, they're trying. A lot of these you can find fish in them. A lot of these you can find mystery snails, yay, and things of that nature occurring in these ponds. White amurs and things of that nature. They're trying, but I think we can do a lot better job very easily with these. And I frequently run up to opposition against vegetation along the shoreline. People that live next to these surprisingly don't want tall weeds, vegetation. They see it as an eyesore. There's really got to be a paradigm shift in what these are and how they function. And I think we've got to look at, providing good habitat, not just the cattail pond. Yeah, cattail ponds, they have a lot of value, but it is a monoculture. A lot of it's invasive. We can do better than that. Another aspect of this that's coming up more frequently is the post-construction aspect with communities. The MS4s are being more and more required to make sure that these are operating as planned. So in that stormwater respect, this is just a typical detail I pulled up of a stormwater pond outlet and some of the controls that are in there, and making sure that these are functioning correctly so that we have a correct functioning stormwater basin. You can see, this takes a little bit of detective work to know what's going on here. The water, when you look at that, water does not flow in from the left and go out in the right. It's actually, the pond would be located on the right of this picture. That standpipe would be the outlet into the discharge pipe going to the left. And all of those holes represent those control levels of that typical pond section that we were looking at for stormwater. So a community, an MS4 that has one of these that they're either maintaining or they're required to make sure that it's operating correctly, need to be aware of these conditions that we're applying to this pond and making sure that it functions correctly. Here's an example of a pond that I was called about and took a look at. This is actually a very old pond. It's been around for about 20 years. And you're looking at the temporary structure that was left on it at construction that was never reconfigured to the final design. So this had never been set up to operate correctly in the first place. And you can see a lot of those holes, this was designed for during construction as a sediment basin. So those holes are there simply to raise the water levels during construction and get some sedimentation out of the water column, and then discharge appropriately at that higher level. The final configuration should have a inverted pipe to the bottom of the pond here and discharging through that into that structure there. This is also tipped over and leaking, and like I say, it just was never finally maintained. Here again, you can see kind of the structures off in the distance there. You can see in around those taller vegetation. You see the pond bottom. It's a very shallow pond. Very little vegetation. They're unhappy with this because they basically have a mud flat part of the year. They see it as a mosquito problem and just eyesore in general. So what can they do about this? Well, the first thing I recommended was they needed to get a hydrology that's working in there. Let's get that figured out. They need to have a working stormwater pond in the first place because this is their post-construction device. So that's another aspect of this. Has it ever been dredged? I doubt it. Are depths are correct? Probably not. This is why something that we do, and something that's going to come up in the future is looking at pond depths, looking at that post-construction aspect. Was the final design met at the end of construction? I have never seen a constructed pond, stormwater pond, dredged at the end of construction. We just assumed that, okay, it had some volume there for sediment. That's probably filled in, and it's good to go into that post-construction aspect. That's not going to work anymore. We need to have some idea of what those bottom contours are. This is just a screenshot of, we have an eye bobber, a very simple sonar device. It's used for fishing, basically. but it allows you to look at the contours, pond contours, and get an idea of, hey, how deep is this? Hey, where do we have sediment loads? You know, what you're seeing here, if you look at that, the bottom is the distance out, so that's about 32 feet out from the shoreline, and then coming back in towards the shore, you can see a couple of humps there, and this was basically a channel created from an inlet where that deposits were going to the outside of the channel, and the sediments were building up. You know, those sediments built up 2 feet there in that off of that discharge. So simple tools to look at and take a look at this, but it's also something that we're going to be looking at in the future relative to MS4s and relative to the post-construction aspect of it. And I think Corey will get into that a little bit more in the Aqueduct presentation. And I think that is my last slide. Let me get back to stop sharing. And I will take a look at some of the chat. What do we have for?
Well, I've been putting a lot of things in there for links kind of based on what you were kind of talking about for some extra info. I think the only real comment other than John's that saw come in was from Kevin, just looking to discuss the desire to use or approve submerged pipes for these ponds, and if others have opinions on that. And so if that's just a separate conversation to kind of go off on, but
I think the design parameters are kind of up to the designer, but something that we really look for is that protected outlet aspect. No longer are the orifice plates with the 1-inch hole kind of an acceptable practice in a stormwater pond. That's just not protected enough, and we see constantly problems with the old ones that have those kind of systems on. So some kind of, the inverted pipe is a good way of protecting that, unless of course water drawdown, you get that surface flows becoming near that inverted pipe. I've seen plastic bags float into, or basketballs even, or just blow up toys from pools, get stuck in those inverted pipes. So some kind of protected outlet is important. What else do we have? Anything else comment-wise? I'm not seeing any. So why don't we go ahead? I will throw it over to Corey Richmond. He's with Aqueduct. I hope everybody's familiar with Aqueduct. They're pretty widespread around here, and we see them constantly. Offer up some of their professional management techniques and some of the things they look at, and I believe where you've also got Peter Quint with you, possibly.
Did he join? I'm not sure if he ever joined.
Yeah, I don't know either.
He's out in the field today.
Okay.
Doing site
Yeah,
visit.
I'm here as well.
Oh yeah,
Hey,
there
Peter.
he is.
Hey.
Yeah.
So
we may throw you some questions if they come in, but again, and everybody, I encourage you to ask questions. This is your opportunity to really talk to these professionals and see what's being done these days and what can we do. So I will, again, Corey, I think we've got the screen shared. I'm seeing it. Everybody's seeing it, I hope, and I'll let you take it away.
Okay, great. Thanks, David. That presentation was awesome. Definitely hit a lot of good points. Mine is not as good as far as the slides, but I want to have more of a discussion type thing. So anybody that has any questions, just use the chat there, and we'll keep this thing rolling and have a discussion at the end if we don't get to it during the actual presentation. So like David said, I'm Corey Richmond with Aqueduct Lake and Pond Management. We're based out of Grove City, Ohio right now. Our Columbus location is. Peter Quint is in our Chardon location. And our Columbus branch is actually moving. We'll be moving in probably two weeks. we're moving up to Lewis Center, right off of High Street and Polaris Parkway, right across the street from High Banks. I'm sure you guys are familiar with that. So excited to do the move. We're going to have more of a retail office up there, and we're going to own the facility. It'll be much more welcoming to customers and professionals in the field, so we can do more stuff like this when we get back to normal, and we can actually have face-to-face discussions. Maybe we can host something like this someday. I think that'd be really cool. So we get started here. There's my information. Yeah, here we go. So construction, this is something that Aqueduct doesn't do in-house. We subcontract out our construction. We don't have excavators or operators. We leave that to the professionals in the excavation field. But just some keynotes. You want a good slope when you're digging these things. A 3-to-1 slope, so for every 3 feet that you go into the pond, you want to go down at least a foot. If you go less than that, you have more nuisance vegetation than you want. David touched on a lot of good notes for how not all vegetation is a nuisance, and in fact it can sequester that phosphorus and keep the stuff that you don't want growing, like algae, from ever happening, and keep those pesky geese out of there too. So it's important to have that good slope. Location of the inflows and outflows. The pond that David showed us had the inflow on the opposite side of the outflow. We've had so many stormwater basins that you'll have the inflow right next to the overflow. So there is absolutely no circulation of that water, and it becomes that stagnant, nasty, mosquito breeding pit with the cyanobacteria and all those scary things that people don't want to live next to. So the location of those inflows and overflows are very important. Maintain a good shoreline, install and then maintain it. Oftentimes these things are dug, and during construction they're just left to be dirt banks, and then you see the furrows going through it and down to the pond. It's carrying all that sediment right down into the bottom of that pond, so you're hyper aging that pond. So like David alluded to, sorry I keep alluding to you, David, but
that's fine. Sounds
you
like I covered everything.
Yeah, you made a lot of great points. Most of the sedimentation over the life of this pond happens in that first month, in that first 6 months, because all of that sediment, not only around the banks there, but as we saw from the curb photo, during construction, if you've been to these homeowners associations and these subdivisions that are popping up everywhere, you go there and there's mud all over the road. There's mud being carried down the curb line, going straight into those storm drains that are leading into those basins, and they're filling up very fast. And so, you lost sometimes 30-40% of your volume before anybody's even living there, and it's leading to problems, specifically with the vegetation, because you have a shallower basin and you have more of a photic zone. The sunlight's getting down to the bottom of the pond, whereas if it was where it was dug to 8 feet deep, sunlight wouldn't be getting down there and causing all those problems. So it's important to install those silt screens. I'm sure you've seen them around a pond. They're usually black and they're staked in with wooden stakes. It's to prevent that sediment from getting into that pond. It hits that silt screen and it piles up on itself. Silt socks around the drains that are on the road, and then there's other things like silt bags that actually go inside of that drain, so you don't even see anything at the surface. And then you have to maintain those because they fill up. And then once they fill up, the sediment's just going, it's hitting that sediment. The sediment's hitting the sediment and running off into the pond. So get those plants in there early if you plan to do emergence. Something really cool. My favorite pond is Mirror Lake at OSU. They did an amazing job planting pickerel weed, arrowhead, arrow arum, bulrush, different kinds of lilies, lizard's tail. These are all very pretty plants. I think when most people hear emergent vegetation, they think cattails or phragmites or these tall grasses where you can't even see the pond anymore. So when you live in these subdivisions where they sell these homes next to these stormwater basins and they call them lakefront properties, people are they're sold a bill of goods that aren't realistic. So but if you can make them understand, make the people that are selling those lots understand, there are cool plants. There are beautiful pickerel weed, that pretty purple flower. That's a very cool plant. Get those in early, let them get established. If you're just doing turf grass, let that get established early so you're not having as much runoff into those basins. As far as the maintenance, now this is right in Aqueduct's wheelhouse. This is what we do. We maintain ponds for algae and weeds. Algae is great in nature as sequestering phosphorus, and it's it is the highest oxygen producer in the world because there's so much of it. But again, people don't like it. It's stringy, it's slimy, it's green, it's just nasty. So with pretty much every basin that we manage, we don't like to see algae, but we do like to see other floating vegetation like American pondweed, Illinois pondweed, things like that, lilies, and then your submerged vegetation too. People don't care about the weeds if they can't see them, if they're under the water surface. So we like to maintain those, the naiads, the sago pondweed, those things. So we always tell people this, we don't sterilize your pond, we're going to manage it. We're going to manage the vegetation. And we have to set those expectations early because some people, they just don't realize that it's not a swimming pool, it's a pond. And it's a part of nature, and it's a part of the system that the develop, because there's rules and regulations set by the EPA that's, the reason for these basins is to get all these pollutants out of them before they go into the creeks and the natural world. So what do we do on our management visits? We stop by every 2 weeks, and the biggest thing we do is we treat the nuisance vegetation, but we also do things like clear the overflows, maintain those orifices like David alluded to, that one riser pipe that had all the dead weeds all over it. We do that every time we're there, every 2 weeks. And you can have that happen every 2 weeks. They could get that bad every 2 weeks with the plastic bags or the Nerf darts. You see them everywhere. The trash bags, I mean, you name it, we've picked it out of a pond. And we've cleared it out of an overflow. So we inspect aeration systems, which is very important. I'm going to get into the aeration systems a little bit later. We make sure they're running appropriately. A lot can go wrong with them. And then we write a service report. We take a picture of the pond and any problem areas, and we send that report to our client with detailed summary of what we did and what potentially they could do to improve that basin. So that's the bulk of what we do. Quick question from Jess Griffith: when a pond overflow runs to a stream, do you have to have okay to apply pesticides? It depends. During construction, yes, we do. After that, it's in Ohio, you do not have to have a permit for each individual basin. Different states, yeah, you do have to have a plan for every time you go, and those are very tough. I've talked with people in Michigan that's very difficult. Imagine every time you mow your grass, you have to get a permit for it. That'd just be very difficult. We are licensed, however, with the state to use these things. Every one of my crew leaders has a degree in environmental science or natural resource management, and we're trained in-house continuously. It's something we take very seriously. So,
Corey, I just wanted to interject there. Some issues that we've had with Pondi in particular was that discharge out of the stormwater system, and EPA looks at that basically as an IDDE issue. Anything that's not stormwater that's getting into the creeks is a problem. So if we're looking at I think that having the operator's license, like you mentioned, is very important, and making sure that you're not dyeing the pond right before a storm event, that kind of thing is very important about this. But be very aware of that discharge to state waters with some of these pond dyes, because they do look at that as non-stormwater, basically.
yeah, we've definitely run into issues where we may have had a new person out there that puts the dye in, or a client that'll go buy the dye themselves.
Yeah.
When we tell them you can't do that, and they'll put it in anyway. So yes, we're very aware of that, and do everything we can to not have that discharge into the state waters or the waters of the U.S. And something else to note while we're on that subject: the life of aquatic pesticides specifically is very short. It's taken up by the plants that we're targeting. We have technology that gets that pesticide exactly where we want it to be with our high pressure pumps, and then that isn't uptaken is quickly broken down, usually same day, if not that same day, a day later. So there are products out there that last in the water column a lot longer. We do not use them because we don't want to treat the creek. We want to treat the pond. So for multiple reasons, that's not something that we do. So aeration. Aeration is very important for any body of water. Get that water circulating. In the natural environment, you have, typically with a lake, you have a creek flowing in and a creek flowing out. That's a serious turnover of that water. What does it do? It precipitates sediment. It precipitates phosphorus. It takes it out of the water column and drops it to the bottom, where it locks into those sediments that are at the bottom of the pond, and keeps them from flowing into the creeks, nearby creeks. It increases your dissolved oxygen. So when you do that, you have a whole bunch of secondary and tertiary benefits. Improved water clarity, improved fish activity. So your fish are going to eat more, they're going to grow more, and they're more fun to catch, so on and so forth. Less nutrient availability, therefore less nuisance vegetation growth. It prevents stagnation, so you don't have the mosquito problem. But like David said, you know, even if you don't stock your pond, fish get in the pond on the feet of blue heron, on the feet of ducks, and they love mosquito larvae. So that's another thing to consider, is getting fish in there early so they can eat any kind of larvae that come in there, especially those nuisance larvae like the mosquitoes or leeches and stuff like that. The upfront cost is pretty manageable, especially when you're dealing with commercial properties or subdivisions. A basic one diffuser unit is going to cost you about $2,000 installed by us, and we are licensed and certified by the manufacturer of like every manufacturer that you can think of, especially the good ones like Air Max, Vertex, Aquamaster, Casco. Those are all really good brands. And we have our guys go to those locations over the winter, and they get certified to work on them. So when we work on them, it doesn't void the warranties. It maintains them. So minimal operating cost. You're pumping air. You're not pumping water. So it doesn't take that much energy. The smallest ones are quarter horsepower. Which is it's less than 300 watts of electricity. So, you know, you're talking $15 a month on the electricity bill. That's nothing for the benefits that you're getting. Maintenance cost is very little as well. You change the filter every 6 months, and you do a maintenance kit on the motor every 2 years. Windmill aeration is I don't recommend it, and I'll tell you why. You need aeration the most when it's not windy, and when it's not windy, your windmill aeration isn't working. So, you know, wind naturally circulates the water as it hits that water surface. It's making that waves and turning that top surface water over. So I do not recommend them. Solar are very expensive, and the technology isn't quite there yet. I think it will be when Tesla starts making solar aeration systems. But the current manufacturers they're trying, but they're just not great. And they're crazy expensive. It's best to just run the electric and get the electric systems. So much less than a fountain as far as the upfront cost and the operating costs. I'll get to that in a second. Easy site requirements, 120 volt outlet. That's all you need outside of your flood zone, because these cabinets, which you see at the top right of my slide there, they can look like that fake rock. That's showing you a see-through, so you can see what the compressor looks like, but it would look like that fake rock looking cabinet. Or you can have a metal cabinet, painted metal. They make all kinds. Your diffuser is next to you there. But that's so the diffuser is what sits in the bottom of the pond. In that lower picture, you can see what it looks like in action, or the middle picture. And that's what it looks like at the surface, just that boil, that bottom right. It's just like a boil at the surface of the pond. So you can do 240 volt too if you want even lesser operating costs. It's really not necessary in my opinion, but if you want to do it, you can. If you already have it there, you might as well. I was getting into, you don't want to put these things in a floodplain or a flood zone because they are electric. They're pumping air. They're made to pump air. When they start pumping water, it's a bad thing. It's really bad for them. And usually that's a new motor. So keep them out of the water. What do you want to put in the water? Fountains. Yay. Fountains are pretty. They're made to be pretty. They're aesthetics. And they are pretty. Instead of the bottom diffused aerator, you can see at the bottom right of my slide there, it's circulating that entire water column. The fountain aerator is sitting on that top foot or 2 feet of water. And so all this water in the bottom of the pond isn't getting circulated, only this top portion. They get clogged by trash bags, plastic bags. Fish get sucked onto them. We've seen them completely covered in caddis flies. That can clog them. So they're made to be pretty, and the maintenance is more expensive because you got to pay us to unclog them if we're not there on the regular maintenance visit. That is included in the regular maintenance visit on our management programs, but it can happen the day after we're there. A plastic bag can float in there, and then we're not there for 2 weeks. So you got to pay to take them out in the winter. You don't want to let these things freeze. That water, that ice freezes around that float and then cracks the float, and you just put your $10,000 fountain in the bottom of your pond, and that is not good. Ruining that engine, that motor. So you can get lights on them, you can get color changing lights. I'm not telling you to not buy fountains. I'm just telling you, if you're going to do one or the other, do bottom diffused aeration, because it's better for water quality. It's better, and they're easier to maintain. Site requirements are a little bit tougher with those two. You do need 240 volt outlet because it has higher power requirements. It's pulling more amperage and therefore more wattage. I don't really like to sell anything less than 1 horsepower, which is equivalent to on a 120 system anyway. So about half of that for the 240, but still, that's a lot of power. You can expect about 60 extra bucks, 70 extra bucks on your electric bill a month. And all those things can go wrong with them. So, yes.
I'm curious if you had any experience with the Solar Bee product. That is basically a solar aerator that circulates bottom water. I haven't seen them around here, and I'm just curious if you've ever ran into any of those around here.
Solar Bee, I have not done. We don't have that as a vendor. So no.
Might check into that, because that's the problem I've seen is all of these electrified products have to, you've got to have that connection somewhere. The Solar Bee is actually a self-contained unit that helps with that bottom circulation. It's kind of a unique device, and I haven't seen them used around here either. I've seen them used in larger lake systems, so I don't know how the applicability is to a smaller system, but it does seem like a solution to when you don't have maybe that electrical connection available.
Yeah, and we, like I said, we have installed those solar systems. Aquamaster, one of our vendors, makes a good system, but to put it in perspective, the Aquamaster solar unit that we sold was $12,000 for 2 diffuser aerator, 2 diffuser system, and the electric system we quoted was about $3,000, so 4 times the cost. If you think about it, they could have used $9,000 of that $9,000 to run the electric out there, and they would have had a more dependable system. But there are those applications where solar is necessary. But I'll check into that. I'll definitely research Solar Bee. So emergent vegetation, getting into this a little bit further. Plants uptake the stuff that we don't want to go into the creeks. David alluded to it several times that we need to get the public's perception of these things away from the negative and more to seeing the beauty and the services that these things provide. For instance, Mirror Lake, we harvested last year. They have a 20 to 30 foot ring around the whole pond that they planted those diverse plants on, and we harvested all of them last year. We didn't spray them, we didn't treat them. We just waited until they drained it for Michigan week because they didn't want any kids to do the Mirror Lake jump. But we waited till they drained it, and then we went in and cut it all out, raked it out, and hauled it out of there. We took it to Kurtz Brothers, and they made mulch out of it for people's flower beds. So we did not do that in 2018, in the fall of 2018, and in the spring of 2019, that pond was a nightmare. Mirror Lake was a nightmare. I don't know if you guys got to see it last spring, but it was covered in algae, and it wasn't just covered, it was like the whole thing was full of algae. And it was because all of those plants that uptook all of those nutrients the previous year died that fall, and as they were decomposing, released it back into the system, and the algae took it and was like, thanks. So I tried to treat it, and it just wasn't working. So they ended up paying another company to come in and manually remove the muck. They were using shovels and pitchforks and everything. I wasn't interested in bidding that one. But they did it, and then that, like I said, last fall we took it all out, and this year it's been easy to manage, super easy. So yeah, we took all that out, and then we made mulch out of it. So everybody's happy. It was expensive for them to do that. We charged them almost $14,000. We had a crew of 8 people there for 2 straight days, cutting and removing and raking, because you can't be too intrusive with those types of things. You don't want to get big equipment in there, excavators, because then you'll rip out the roots, and you don't want to do that. We wanted all that vegetation to come back. But those monocultures are bad. Monocultures of cattails, whether it be narrowleaf or common, they are a nuisance because they will invade a pond, and what was 100 square feet last year is 1,000 square feet this year, and next year it's going to be 10,000 square feet. And then you can't see your pond, you can't use it. We do not recommend them. They're good for those natural ponds out in nature, but I don't recommend them for these subdivisions and commercial properties. Yes, they'll keep out the geese, but so will bulrush and pickerelweed and things like that. So go that way. Don't let the cattails and the willows and the phragmites take over. Phragmites can get like 14 feet tall. So you won't even know the pond's there. And then after we do that once, so not for Mirror Lake because we didn't treat them, but for the subdivisions, once we treat them and remove them, we include that management of the cattails and phragmites and willows for the remainder of that pond's life. We will let sedges grow. We will let rushes grow, but not those nuisance plants. So
when you said you took the
I lost him.
I did too.
explain that a little bit?
I lost you there for a second. Could you ask that again?
Can you tell me how you guys dealt with Kurtz Brothers on taking the remnants of the cattails and they don't have a problem with that, with the you're talking about just the plant, not the root ball? Correct.
Yep. We took it with a dump trailer and to their big Frank Road facility, and just as homeowners and landscape companies take the leaves over there, we took the vegetation there.
Okay. You have any ideas what you do if you go in and dredge and you dig out the cattails? We're having issues getting rid of that scenario, the muck
Right, because then you have all the sediment along with it. We don't run into that. I know where we've had that issue, or our excavators have had that issue in the past. They'll bury them. They'll find a site away from the construction site and just bury the cattails.
I would say disposal of those sediments does become a problem, especially when we're talking stormwater ponds. You know, a lot of those, you know, we might be looking at heavy metals, you know, some undesirable things there as well in those sediments.
I guess what's your thoughts on if you take it, you pile it, you work it till you get it dried out, and blending it with other dirt for fill or whatever once you get it dried out?
Yeah, definitely. The on-site disposal is a preferred option for sure.
Okay, we're kind of looking at that. We've talked around the office here about maybe finding a parcel to lease for a few years up in that area where we have the ponds. We've got a lot of that to clean up, and just leasing a site, trying to work a contract out with the property owner and using that site as our disposal site till we can work it and see how that works out.
I've seen some use of as a beneficial use product for farmlands. That may be possible. I think it just depends on the sediments, and we don't want to get to the point where we have to be testing sediments from stormwater ponds for this maintenance purposes. This needs to be something that is, you know, we've allowed it. John kind of alluded to what's allowed to go into a stormwater pond in the first place. And well, you know, from a permit standpoint, it's whatever's in the stormwater, basically, in non-point source kind of levels. You know, once you start dumping or there's obvious oil sheens or things like that, that might be a problem. But stormwater, non-point source kind of sources, that's what the ponds are for. So how we get rid of those sediments, though, can be problematic.
Yeah, that's what we're running into. So maybe we can talk a little bit later, Dave and Brooke.
Yeah.
Ideas. So, okay, thanks.
Sure.
Thanks for chiming in too. Again, you know, this is our roundtable. Feel free to chime in or leave the chat. We're getting some chat questions. I did see one we didn't quite address. Is Mirror Lake quite a bit different than what we would see in regards to our typical retention basins? May not have the depth and is fed by a well. Corey, you got any input on that?
Yeah, so Mirror Lake is different. It's got so it comes in. There's a shelf where all that emergent vegetation is planted. And then it's a straight drop to 4 feet deep, and then it's flat across the bottom, 4 feet deep across the entire basin. Whereas most ponds are, you know, 3 to 1 all the way down until they get to that depth, and there's different contours and things like that. But it could be, any pond could get those types of plants along the shoreline. You just, if you had a steeper bank, you would have to stake them in or put an anchor on them, as they did with the islands, the floating islands. So well water can be tough on plants because it's so hard, filled with those carbonates. So you might want to have that tested prior to attempting planting. I had a pond in Marble Cliff that had hardness over 700 parts per million, and the bicarbonates, calcium bicarbonates. So nothing but your very hard water algae can grow in that pond. And then Brooke's sending those out. Yep.
And I did get a private comment just from
You
John
do.
over at Fairfield, just reminding also when it comes to aquatic plant management with ponds, just making sure of keeping growth off of dam sections or areas like that where you might have woody, debris and root intrusion and things like that, or where you need to maintenance structures. You know, just being mindful of that as you're managing.
Yeah, very important. Don't let trees grow on your dam. Keep them mowed. When you're designing these or excavating these, make it so that bank on the backside of the dam can be mowed. Don't make it a straight down drop. Make it think about maintenance when you're digging these things, or when you're designing neighborhoods around them. You know, we have surrounded by houses, and you can't get an excavator back there. I mean, what do you think you're going to do? Drop a excavator in by a helicopter? It's just not going to happen. So think about those types of things. Dredging, I'm going to get through 3 more slides quickly. Dredging, it's very expensive. Every pond fills in over time, whether it's a natural pond or these stormwater basins. The stormwater basins usually fill in a lot faster because you have all that impervious pavement that's feeding into them. So, you know, all that dirt that's getting on the road is going in there. So they do need to be dredged, and it's usually in the maintenance package for that development bid that these developers have to turn into the EPA to get approved. And it's usually like 10 years or after post-construction. And do you know how often that's actually done? Never. It usually happens when we've been managing a property for 10 years, and it was decent in year 1. Year 5 we started to get problems. Then year 10 we just cannot keep up with the amount of algae growth, and we say we're trying to maintain this pond that's 2 feet deep across the entire thing. It's filled in with muck, it's filled in with sediment. We just can't. You need to have a dredge. And they were like, oh yeah, well, let's do that. And they get a bid for $150,000, and they're like, we'll just keep paying you $1,000 a year. So it's just okay. So plan ahead, budget for it. If you guys talk to these board members, if you talk to these property management companies, just get them to budget for these things. You have to dig them out eventually.
Hey, Corey, just a quick question on that. Since you guys contract out any of that excavation work, if you have a client that can do dredging or something like that, do you look at ways, or have the excavator look at ways to like maybe reshape ponds that maybe are older to like create like better forebays or things where might reduce, you know, future maintenance or not be as cumbersome in the future?
Yes, I'm glad you brought up forebays too. Yes, we recommend most of the time Noble Excavating. He specializes in ponds, and yes, he will dig the slopes to what they should be. And you know, if they're looking for having a deeper section where the stormwater is coming in, so that the sediment builds up there, he can do that. And that's very important for any excavators out there doing that. Where is that water coming in, and how can you manage that sediment coming in so that you don't have to do these dredge projects every 10 years or even more often? Forebays is the answer, and then you have to maintain those forebays. We hardly ever see them. And where we do see them, it's so much easier. It's a you know, 20 by 20 or 30 by 30 circular basin that fills in with the sediment and then fills in with the stormwater coming off, which then the sediment precipitates out of, and then it overflows into the pond. So you don't have to dredge the pond. You dig out that forebay every so often, and it's so much easier. So definitely recommend those more often than not. So getting through these. Fish, talking about fish, don't put grass carp or white eamers in your pond. Just don't do it. They're not native to this region. Nothing is going to eat them unless you get a blue heron whose eyes are bigger than his stomach, which they try. You'll see them every once in a while. You'll see the grass carp with a gash in its back from a blue heron trying or a hawk trying, but never seen one succeed because they're like 40 pounds and they're only adding to that nutrient load that's in that pond. They're eating the plants which are sequestering that phosphorus, and then they're pooping it out so it's in a even more dissolved form so that it can be taken by algae. Don't recommend them at all. Don't do it. Bluegill and largemouth bass is really all you need to have a good ecosystem in these stormwater ponds. They love that larvae, that nuisance insect larva, and they're fun to catch and they're easy to catch for the kids that want to have some fun outside. That's all you need. And if you want, you can stock feeders every fall. Fathead minnows is the easiest thing to do, but it's really not necessary. Most of our systems are so eutrophic that they have plenty of plankton and macroinvertebrates to snack on. So it's really not necessary. Plus, you're adding more biomass and therefore more nutrients into that basin. And like I said earlier, they'll get in there whether you stock them in there or not, on the feed of waterfowl or during flood events. So I know that was really long, and I apologize for that. But I hope you guys got something out of it, and let me know if you have any questions.
Yeah, we appreciate it, Corey. Thank you for doing that for us. That's a heck of a fish, by the way. If they tasted good, we wouldn't have that kind of problem with these
Right.
ponds, you know?
Slimy. Nasty.
So Corey, I hope you can stick around and maybe check the chat and answer questions. What do we got on the chat? Anything pending right now?
I got them all. I think we got them all.
Okay, awesome. Well, then let's move on. Are we ready, Mark? I see you're in the house and ready to go.
Yeah.
Mark Dilley with
Right.
Mad Scientists. We appreciate you
Hey, Corey.
joining this. Go ahead.
Sorry, I think you're still sharing your screen, maybe. You can,
Yeah, let me get off that.
I wanted to comment. I think that's probably the strangest modeling job that woman ever had.
How do I get off of? Oh, stop share. I see.
Stop sharing. Yeah.
There we go.
There you go.
Awesome.
There's actually a lot of the fishing models nowadays.
Yeah. Well, thanks, Corey, and thanks, David. Appreciated all of your comments thus far. I'll go ahead and get to sharing a screen here. Let's see here. My cursor just disappeared on me. There we go.
Yeah, some of this technology we gotta work on and get used to, but I think everybody's been busy using it for the past 6 months, so we should be getting a handle on this.
Yep. There we go. Are you seeing slide set for me now?
Yes, we are.
Okay. For some reason, it doesn't appear for me, but as long as you're seeing it, that's the important thing. So I guess I will probably hop on essentially the same soapbox that David was on, but I've entitled my talk, Stormwater Ponds, Why Stop at One Function? And for those of you who don't know me, our business, Mad Scientist Associates, does a lot of wetland related work, and that's really our forte and where a lot of our projects lie is with wetlands. So I tend to look at stormwater ponds often as missed opportunities to restore greater function to our urbanizing landscapes. Some of the more conventional, steep-sided, rock-lined detention, retention ponds are, in my estimation, missed opportunities to do something creative. So I want to provide a little bit of history here. Let's see. See if my slides will advance here. There we go. I'll mention that I'm the current president of the Ohio Wetlands Association, and I teach a wetland ecology class at Ohio State University. So I'm talking on these points frequently, but want to provide the audience a quick overview of the history of wetlands in the United States. Since European settlement, we've seen a lot of draining and filling of these wetlands. In the lower 48 states, it's estimated that we have about a 50% loss of wetland area. And in Ohio, that number exceeds 90% of our original wetland area. And as wetlands disappeared from the landscape, the conservation community, particularly hunters, waterfowl hunters, noticed that we were seeing the repercussions of wetland loss, initially with the decline in waterfowl populations. And this kind of drew interest to wetland resources and the state of our wetland resources around the country. There was a growing awareness of the various ecosystem services that these wetlands offer, and a national effort initiated or formalized under George H.W. Bush as president to try to reach a state of no net loss of wetlands, which is why we mitigate any wetland impacts that we have currently through a permit process, and we build new wetlands to replace those that are lost to try to meet this no net loss goal. In 2005, the UN, the United Nations, put together this Millennium Ecosystem Assessment, and they looked at wetlands as one of the ecosystems and focused on some of the services that were provided by these important ecosystems. And in this particular graphic, the larger dots represent more significant levels of service to humanity in terms of food provision, fiber and fuel provision. The abundance of fresh water that can be found in wetlands was identified as a provisioning service. And then we have regulating services, which tends to be our focus when we're talking about stormwater ponds and detention, regulating hydrologic regimes, reducing erosion, avoiding flooding, natural hazards, and also providing some climate regulation services. And then this ecosystem assessment also looked at cultural services, including just the fact that these are fun places to visit, places where people kind of connect with nature, sometimes in a spiritual or inspirational sense, and there are lots of beautiful settings and recreational opportunities provided by these systems. So this table is one that I put together just kind of showing some of the main services that are offered in wetlands, and I've lined up a comparison with the level of services that we might see in a conventional storm basin. And in every case, pretty much for every category, things are kind of steady or providing a lower level of service. Storm ponds are great for flood protection and erosion protection, but they offer very minimal value outside of those two services. And this is what they often will look like. Not an area that somebody's going to want to spend an abundance of time at. You don't particularly enjoy nature, although I've seen turtles in this pond and certainly geese. Here's a detention basin. And this is the project that David alluded to. He knew I was going to touch on this one, I think. This was a rather poorly designed detention within a community, and the Soil and Water Conservation District hired a consultant to redesign the site, and then our firm was actually involved in the revegetation effort to kind of provide an upgrade for the site, and I'll show you a few slides of that. By comparison, this is a wetland and what a wetland can look like. This is one of our projects in Westerville in one of the parks, and I'll talk about that a little bit later. But I would argue that this is much more aesthetically pleasing than either of the previous images. So here's the pond. There's David and Kyle walking around this detention basin. And after the site was reconfigured, it directed storm flows through this area, if you can see where my cursor is, out around a low berm and through this larger section of marsh habitat, extending the flow length of the water, the storm water that was passing through, so that there were greater opportunities to remove sediment, nutrients, and generally improve water quality, because the inflow was about where my cursor is here, and the outflow was just on the other side of the trees there. And so the whole basin was essentially short-circuiting and not really providing much water quality benefit. So that was all reconfigured with the plans that the SWCD paid for, and really improved the appearance of the site and the habitat value. So when we talk about ecosystem services, I think it's important to note that wetlands are incredibly important in terms of maintenance of biological diversity. And in stormwater ponds, we can't really have super high expectations for maintaining biological diversity, but even common species in urbanizing areas can be at risk of being extirpated from the area due to lack of habitat. And so even these rather common sorts of settings can provide some valuable habitat that bring wildlife back into view for people and can conserve local populations. There are some statistics that say about half of our threatened and endangered species rely on wetlands at some point in their life cycle. And again, urban wetlands are probably not going to serve much of a role in bolstering threatened and endangered species populations, because there are other aspects of the environment that are probably not going to be suitable. But even maintaining local populations of common things like American toads can be really valuable. This is just an interesting factoid on the value of wetlands in preserving biological diversity. This shows the percentage of threatened and endangered species that are listed as threatened and endangered that rely on wetlands during some part of their life cycle. And you can see how critically important wetlands are, particularly to fish, reptiles, mussels, birds, and amphibians. So in urban environments, we have lots of wildlife that can use these systems if they're made available. This is an American toad. Certainly we have lots of mallards and other common waterfowl that can occupy these spaces. And as has been mentioned, if you get a lot of tall vegetation growing around the perimeter of your pond, you can reduce nuisance populations of geese, but you may still have some waterfowl, which most people will appreciate. Even geese coming into a pond, as long as they kind of fly in and spend some time swimming around and then fly back out again, versus milling and depositing their feces all around the edge of the pond, is certainly preferable. And a lot of the vegetation that establishes around wetlands provides important pollinator resources. So these areas can be very attractive to the public and also good for our pollinator populations, which we're increasingly concerned about maintaining. We have different types of aquatic organisms. This is a big diving beetle. That's a helpful predator in your pond to help to curb problems with more nuisance organisms, as Corey referred to. We have nesting habitat for things like red-winged blackbirds that will nest in cattail and other tall reeds, and even reptiles like this painted turtle and gray tree frogs. This is a young gray tree frog, still has a little stump of a tail that hatched out of our wetland at Highlands Park in Westerville. And it's perched on a plant called water plantain. And this is another view of the wetland. I threw this in just to emphasize the value of sites like this for public education and giving children an opportunity to really get close to nature and connect with it. I'll talk about that project a little bit more momentarily. So one of the things that I've noticed, and I've attended some stormwater conferences and talked about this, is that you know, we're seeing increased efforts at incorporating green infrastructure into our landscapes, and this is really important work that's going on to slow the rate of water moving into our rivers and streams, because it reduces erosion and provides a lot of benefits. Columbus has this blueprint stormwater strategic plan, and out of curiosity, I scanned through it, and here's some word counts of where these different terms show up, or how frequently these show up within the manual. The word wetland appears once, and it's in this table to the right, which basically just says that a wetland is a basin that provides a filtration effect and infiltrators, but then there's no other set of instructions or a blueprint, as it were, for how to build a functional stormwater wetland. So I feel like we have room for improvement in actually kind of providing a design template that can be used in situations where designers, engineers want to get a little more creative to provide these additional ecosystem services as a part of their project. So here's an example I wanted to share. This is a specific wetland project that we referred to as a detention basin retrofit. This is a project that was done for the New Albany Plain Local School District. And I think it highlights a lot of important points when we're thinking about how we manage stormwater and what opportunities maybe are evading us because we've not taken the time to think about wetlands as a possible solution in these stormwater management settings. So what I have here is a project that involved a basin, a storm detention basin that was used by the environmental studies program at New Albany. They actually had put netting over this storm pond so that they could use it as an aviary to raise wood ducks for the Division of Wildlife. Kind of a cool little project, because the students got to tend to these ducks and make sure they were safe, and they'd raise them up to adult size and then release them. So we would bolster our wood duck populations. Kind of interesting. But it was not much of a pond because it was one of those more conventional rock-lined holes in the ground. The water that passed through this basin entered a stream and wetland complex that fed into the green space, the land lab that the school uses for most of their environmental studies. So it had an important potential role in improving water quality. And then during a campus expansion, they created another temporary sedimentation basin just south of where this pond was as their sediment BMP. And we were able to, when the work was done, merge both of those areas so that they could be retrofitted as a larger stormwater wetland basin. And the construction here was completed in 2014. Hard to believe it was that long ago. So here's an aerial from 2010, which shows the kind of aviary pond area. They had built a little island for the ducks, and they had I think a board that they just laid down from the shore out to the island so they could go out and care for their ducks. But that was the original detention basin for the school. And then this other white polygon shows where the temporary sediment pond was built. And there was also a structure that was ultimately removed before this storm detention pond wetland retrofit. So we had the ability to create a fairly large footprint area with this crazy looking schematic. We came up with 3 different design alternatives, and this is the one that the school really liked. But each of these pink rectangles represents a storm inlet, and there's also a storm inlet here. This first large pool served as forebay, which was mentioned by Corey, to drop out sediments coming off of the parking lots and from the construction area of the property. And water would build in there and then force its way through these light blue signature areas. So we were spreading the water out and moving it slowly through the detention basin over to an outlet where it would drain through a pipe and then out into the rest of the land lab. And we had a well-timed Google Earth aerial satellite shot that kind of showed what this site looked like when it had some water filling into it. It was pretty much a mud pit at that point, but we got a nice photo out of it. And then a year later, everything had greened up, and you can still see those white polygons kind of showing where the original features had been, how that all ties together. So what had been the temporary sed pond became most of our forebay.
Mark, I just wanted to quickly comment on that picture. You know, something that we've seen on newly constructed ponds is the algae bloom that occurs shortly thereafter. And I think that's really related to those new sediments exposed and being subjected to that water column.
Yes.
We've seen that pretty frequently in ponds, on new ponds, is that rapid algae bloom in the first couple of years.
Yeah, there's a rapid release, you're correct. And it does settle down over time, especially if you can get a macrophyte community in there sponging up as much of the nutrients as possible, so that there's less phosphorus available in the water column for algal growth. So this is the guy that was calling the shots. I referred to him as our supreme wetland overlord. He liked to watch the construction. He said that this was one of his favorite projects to date. And for those of you who know Bill Resch, he's a hoot and a real antagonizer, I would say. You know, when he wants to get something done, he manages to get it done. He rattles a lot of cages, but this was kind of his baby, and we had the good fortune to do the design for him. So he really relished his work on this project. So this is a view across the site after construction. We had some pretty nice soils to work with, as you can probably tell from this image. The outlet in this image had a skimmer initially because we knew we were going to have a lot of sediment moving around, and so we were trying to take the cleanest water off of the water surface. And if there was an overfill, there was a catch basin grate at the top of this that would allow a lot of water to pour out of the site, but it was protected with a dandy bag, kind of a filter system. We ordered a ton of plants. We had a really, the good fortune, I guess, of being involved with Columbus State, and they had obtained a grant from AEP to be involved with this project. and they had $20,000 available that needed to be more or less earmarked for plant material, which is a pretty healthy planting budget. And we got all this material ordered and organized for the school. And then over the course of a couple of weeks, every grade level participated in planting efforts at the site, going from kindergarten all the way through seniors in high school, all assisted by my team and students from Columbus State. And we marked out the appropriate zones for these different plant materials and gave the kids the opportunity to learn about the environment and contribute to this project, which was really a special learning opportunity. One of the things we really like about doing projects like this is that you can create these unique educational opportunities and you really get your citizens engaged. Kids love it. It's a great experience, and they grow up knowing that they had a hand in the project. They're stakeholders, they're caretakers, and they're very interested in the end result. So it's a good way to connect with the public. So this is soon after planting, as things were starting to take and green up across the site. A little bit later in the season, and again with the good soils and the intermittent wetting and drying across this area, we really developed a lot of lush green vegetation. Perhaps more cattail than we would have liked, but it's hard to avoid cattail. And from a water quality perspective, cattail does a great job because it's a big biomass producer. It's very nutrient hungry at cleansing the water. So here we have a nice green space that's been created. It's used by the students as an outdoor learning space. The structure back here is a solar building that Bill Resch managed to finagle from the Columbus Zoo and Ohio State. I think there was some kind of collaboration there. And it's been reassembled on school property as their outpost for learning in this area. So we have water quality improvement occurring within this basin. We have habitat, things that the public can appreciate and learn from. And we still have that essential flood control. You can see in the background, that's where the water enters, and the elevation difference across the entirety of this wetland area between the water surface you see and where that pipe is represents available flood storage. It can fill and the vegetation will be underwater for a period of time, but then it'll settle down and your vegetation is re-exposed, and the plants that we put in there can tolerate that kind of hydrology. So we're still meeting that stormwater requirement. If I have just a couple minutes, I was going to just point out one other project in Westerville. This is Highlands Park. And the thing that I want to emphasize here is the connectedness of the green infrastructure and the wetland restoration. So this is Highlands Park in the 1950s when it was just drained hydric soil. It was a farm field. And the city acquired it as parkland, and the drain tiles started to fail. And what we ended up with was this expanse, this kind of brown, shaggy looking signature area, which was an expanse of invasive cattail, the broadleaf and narrow-leafed hybrid covering most of the site. We took a storm detention basin here that you can't see in the aerial, and retrofitted that as a wetland area, and then we redesigned the wetland area to extend the flow path from a stormwater entry point at the north end all the way down to its exit point to a tributary of Alum Creek called Spring Run. And we extended the flow length by creating these berms that kind of extend out across the flow path so that the water has to move back and forth in kind of a sluggish stream-like fashion, passing it through a lot of vegetation to improve water quality. And here's an aerial where you can see this had been the original storm detention basin for the park, and we softened the edges a little bit and revegetated it, and it became part of this overall water treatment system. And another team from the engineering company that was working with the city put in bioswales in the parking areas. So these green strips are depressional trough-like areas that they planted wetland vegetation in. So we have green infrastructure in the parking lots. In this southernmost area of the site, there's actually some permeable pavement areas and a rain garden out in front of the community pool site. And all of those green infrastructure features outlet to pipes that then come into this storm detention basin, which was retrofitted as a wetland. And then they'll move from about where my cursor is through a culvert out into the main wetland area for additional treatment benefits before the water outlets to Spring Run. So there's lots of opportunities, I think, to merge these different approaches to water management, to stormwater management, where the green infrastructure is there providing initial treatment, and then we have wetlands providing some water quality polishing, as well as providing habitat and the other ecosystem services that we've discussed. So, are there any questions?
Yeah, let's got questions. I check the chat here. If you guys are ever looking for, a good example locally of kind of the wetlands and stormwater, this site is one that I particularly like, the aesthetics of it. It is really quite a pretty site. And I think that's something that we should all strive to kind of get planned and really look at the ecosystem services of ponds in general. I don't care if it's stormwater, if it's a residential pond, whatever. Consider ecosystem services beyond the stormwater aspect and what we can do to improve these. Let's see. I'm not seeing questions in the chat. Brooke, do you have any additions to this?
I don't have any extra ones in there, but I did want to. I'm just uploading. I noticed Jerry France was on the line there. Jerry had sent me a little information on a product that I thought I'd at least share the information with everybody. And I don't know if Jerry, if you want to unmute yourself, if you wanted to chat a little bit to that. I think we've got a little bit of time, and while we give people a chance to maybe ask some more questions into the chat box there.
Yeah, Brooke, thanks. Everyone hear me?
Yep.
Oh, great. One of the things that I wanted to share while you had your roundtable discussion was a new product that Meredith Brothers carries now. Is called, from Abtech Industries, Smart Sponge Technology, which can absorb hydrocarbons, heavy metals, and bacteria that can be used in either in the pipe applications or even a vault to absorb, or even in catch basins as well, to clean the stormwater from before it gets into the ponds, streams, and rivers. And I shared information with you, Brooke. If you could send that to everyone, that'd be great. And
yep,
my contact information as well.
Perfect. Yeah, I put it in the chat box there as the PDF file, and then I will include it as well in the resources next week as well.
Great. And maybe sometime in the future I can get more involved with another program.
Yeah, absolutely. I think that this is definitely one of those topics that every year we could kind of do an updated stormwater pond maintenance discussion. And I know we're looking to get a little bit more involved with some of the future maintenance and looking at some community work. We had hoped to do some of that this year, but with COVID, a lot of things kind of got pushed down the line a little bit. So I think next year we'll have some other stuff to add in as well, and it'd be great to have some more participation from vendors and different products and how people are going about things, maybe actually have some demonstration sites. So yeah, definitely we'll make sure to keep everybody in the loop, and if you want to do something, just reach out to us.
These are definitely the tools in the toolbox. So, getting those words out of what we can use and where we can use it, I think that's an important thing. And it's also becoming something a little more apparent in the permitting and the MS4 permits too. We're seeing some changes in some performance standards where perhaps, in the future, this will be much more needed to show that we're doing some decreases in those TMDL numbers. So it's definitely tools that we can use and consider using. I was going to mention so also in the permit was the new permit that's coming up that will be out shortly for MS4s is some of those performance standards, and that project that you saw Mark in his presentation, the public participation aspect of it, that's been included as kind of one of the performance standards in there. So if you have those opportunities in your community to do something like that, this can be something that applies to your compliance with the MS4 permit. Just wanted to point that out. Those things, we are seeing some kind of changes in the future regarding this. Like I said, there are those permit aspects in the Great Lakes, Chesapeake Bay, but I think that we'll probably see that more widespread, certainly in the future, and that focus on water quality. With that said, we are a little over time. Yeah, go ahead.
Sorry, just Laura had a question come in there just asking about regulations with dry basins. Is there any restrictions on allowing trees to be planted within dry basins, or do you need to?
I would only say from the maintenance aspect in a dry basin, and it depends on the dry basin. A lot of what we're calling dry basins kind of don't end up being dry basins because they need the forebays, so they actually have a permanent pool in them. Whether or not, a lot of people don't like that dry basin aspect that's been built in the past. Generally, you see those concrete lined channel and turf grass. That is people's perception of what a dry basin is. Once you start putting in that forebay and micropool aspect, you've got the standing water. People don't like that because of that perceived mosquito problem, but they've got to have that permanent pool so you're not losing the predators that are taking care of the mosquito problem. So the dry basin aspect, I think if you're going to that strictly detention flow, you might be able to get away with planting trees in there. Beyond that, there's that maintenance aspect as well.
Yeah, I guess that's a good point. Like down the road, you may need to remove those for maintenance, so you might not get full growth out of them depending on where they're at.
I think we're a bit over our time. I'm amazed. I was worried we couldn't fill 2 hours, but we've done that successfully.
Yeah.
I appreciate all of your help and your input on this. Thank you for attending this once again, and look forward to Stormwater Awareness Week and how you can participate. If you need information on that, feel free to contact us. And with that, if there's no more, I will end this and say thank you.
Oh, yeah. Yep, I think that's good. John just had a follow-up to Laura's, nothing preventing trees in the MPDS permit, but just being mindful of where they're placed and whether they might cause berm failures depending on where they are.
Yeah,
so correct. Yeah, just that reminder. Good reminder, John.
Thanks again to our speakers.
Yep,
I
and
appreciate it.
I'll send out resources, recording certificates next week. So look for that in your emails, and there'll be a lot of stuff in there. So holler at us if you need anything.
Sounds good. Thanks for the invitation to participate.
Yeah, thanks, Mark. You always have the best pictures.
Oh.
Thanks, Corey.
Thanks, guys. See ya.
Thanks, Jerry. Yep.
Bye-bye.